Nice. This will be a review of what we talked about with parametric stuff. So let's do this. Scheisse. They give me so much room to work with. Okay. All right. So I think with the little bit we've done with parametric stuff, well, shit. Here we go. A pen. Yay. I think you guys will agree that it's not that bad. So see if we remember how the hell this works. So if you missed my whole lecture, too bad. I like it. It's the Etch-a-Sketch. Somehow Etch-a-Sketch came into play. So I like that. I can't remember when I came up with that, but it's you're the T, and you're controlling X and Y. So X, when you turn one knob on an Etch-a-Sketch, it goes left and right. The other knob, it goes up and down. That's so freaking stupid beautiful. That's X, Y. I'm T. I can move this independent of this. These don't directly relate to each other. They both depend on me. Are you guys at all with me? Does T show up on the graph? Nope, it's behind the scenes. T is the guy that's creating the points. And then I plot the points that T created. So help me out. What can I put in for T? Yeah, so -4 to 4. So most problems are going to tell you some interval that T lives on. Real quick. What is the biggest output? What is the biggest value X could take on? And what's the smallest value X can take on? Not in general, not X everywhere in the universe, I mean that X.
4.
4 and -4, right? Because it's sine goes 1 and -1, it's being multiplied by 4. So somehow this graph, the points are going to have to live between -4 and 4, and the sign, so it's going to be some kind of a pattern between -4 and 4. It's going to be nifty. Okay, I can't remember what this looks like, to be honest, but I think Past Jeff did okay here. So let's start with -4. All right, so I pick the value for T within the domain that they give me. What do I get when I plug a -4 in here? I get sine of, when I plug a -4 in there, what do I get inside? -4 pi over 2, right? So it's -2 pi. What's sine of -2 pi?
0.
Beautiful. So X is 0. So we're making our first point. We've made half of our first point. When I plug a -4 into this dude, what do I get? -4 squared is 16½ minus 4. Dudular. All right, let's try -3. I'm really hoping I don't need better resolution than this. That would be kind of a long thing. We'll see. We'll see what happens. So -3 pi over 2. Where's -3 pi over 2?
Second quadrant.
It's not really in a quadrant. Bless you.
It's the equivalent of pi, right? Pi over 2.
Yes, pi over 2. If I go back 3 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2.
Oh, yeah.
Right? Bless you.
So 0 again.
So what is sine here? 1. So I get 1 times 4. 4. That's crazy. And if I put a -3 in there, it's going to be a little bit more gross, but oh well. -3 squared is 9. Divided by 2 is 4.5. Minus 4 is 0.5. Is everybody decent with that? Okay. -2. Do you guys see how any even T is going to end up with 0?
Yeah.
Because it'll divide and it'll be on the x-axis. Yes, it'll be some multiple of pi, so then that's going to be 0. Here, -2 squared is 4. I had cut in half is 2 minus 4 is -2. Yeah, that's all shit we can do. -1. Now it's -pi over 2 inside, right? So what's sine now?
3, or,
Now it's negative pi over 2, correct? When I put a negative 1, I get negative pi over 2. So I'm here now.
3 pi over 2.
Sure, it's the same as 3 pi over 2, so what's sine? That's all I care about. What's sine?
Negative 1?
Negative 1. Negative 1 times 4. Plug a negative 1 here. Negative 1 squared is 1. Half 1, then 1 half. Minus 1, 7 half. It's negative. Sorry. Negative 3.5. Right. That's the auctioneering approach to math. 0 is sine of 0.
5. Or 0.
Okay. And then if I play 0 in there, what do I get?
0.
No.
Negative 4.
Negative 4. Yeah. You're okay. All right. And then we got 1. Oh, this is exciting. Let's see if we can bust through this. 1 is pi over 2. Sine of pi over 2 is 1 times 4 is 4. By the way, you see the pattern here?
Yeah.
I don't have to do any work anymore for that, do I? I don't have to do any freaking work for that anymore, do I? I see the pattern. Screw the work. Over here, when I put a 1 in, then I'm also going to notice something here. 1 half minus 4. Do you see how I'm going to start to repeat this stuff in the backwards way? Because it's a parabola. It's going to start to go back up, right? So this is going to happen a decent amount of the time. So it looks like I have a lot of work and I don't. So 2, what's this going to be? 0. What's this going to be?
Negative 2.
Negative 2.
Wait, but wouldn't it be negative 4? Not 4.
No. Nope. Why? Here, you mean?
Yeah.
When you plug a 1 in, plug a 1 in. Here, right? This one.
Yes.
When you plug a 1 in, you get pi over 2 inside. Sine of pi over 2 is 1. Times 4 is 4.
Okay.
Yeah. What's this going to be now? Follow the pattern.
Negative 4.
Negative 4. And what's this going to be now? Follow the pattern. 0.5. 0.5. Positive. 4. What's this going to be? Follow the pattern. 0. Follow the pattern. Follow the pattern. 4. So now I'm going to do this for myself. Trust me. Your eyeballs will roam. I kind of do this so I can, when I look, I'm like, these are my points. This doesn't mean shit to me right now. You did good work, T, but you don't mean shit to me now. Whatever, Jeff. All right. So 0, 4. So now it's just plotting points. 0, 4. 4.5. So far I'm kind of going, wee. 0, negative 2. Wee. Do you remember this? I talked about this real quick. You can actually tell me what direction this is going.
Yeah.
That's why parametric equations are good. And I keep going to like missiles and shit because you program a missile's trajectory in using mathematics. It's crazy. So you can actually use parametric equations. We would use 3-dimensional parametric equations because I want my missile to be able to go all over the damn place, right? Actually, I don't want missiles to go anywhere, but too bad. I keep going. Negative 4, negative 3.5. So negative 4, negative 3.5. You can do it, Jeff. There it is, buddy. Good job. Whee! Is everybody with me? I'm just plotting points and connecting them. I could have maybe gotten more resolution, but I think you all agree this should be curvy, right?
Yeah.
This shouldn't be a straight line. It should be curvy. I am making a few assumptions, but who cares? 0, negative 4. So now I'm whee. 4, negative 3.5. Now it looks like it's going to start to mirror itself. What did I just do? 4. Oh, I did okay. What did I do okay over there? Yes, I did. Whee! 0, negative 2. I came back to there. Whee! Negative 4.5. Now I'm back up here. Whee! And then 0, 4. Now I'm back up there. Look at that shit. Look at that shit. Gaze upon this shit here. Parametric equations are so freaking cool, especially when you throw, let me say this word, bounded functions. Which one of these functions is bounded?
the sun.
Yes, it's bounded between -4 and 4, right? This function is not bounded. Doesn't it go to infinity in one direction? You guys semi with me? Okay. So whatever the full, if I go forever, if I let t go to -infinity to infinity, this is going to exist between there. Is everybody cool with that? Those aren't asymptotes, by the way. This is just, it's going to exist between there. So it's going to bounce back and forth between those. Why? Because x is going to bounce between -4 and 4. Okay, maybe. Does anyone think that's nifty? An equation led to this picture. You have to be interested in that fact. All right. You won't accept it if you say you're not. Okay. All right, do number 2 real quick. Oh, wait. Oh, yeah. Let's see. That's awesome. That's not very good, darn it. Yeah, it's better. Okay. Okay. That'll work. All right, let me start to catch up to you guys. Oh boy. Leave some room. 0, 0, 1. 2. Is that right? Does that seem right? That doesn't seem right, Jeff. Pause. Give me a second. 3. 3. I think this is 0, right?
Yeah.
And then 3. Up 2, up 2, up 2. Okay, that looks good. Does this one look good? Are you guys getting those numbers?
I got +4 for 2.
Probably. Let me see. 8 minus
Oh, wait, no.
12.
Nope.
Yeah, should be negative for you.
Yeah.
You guys all with me? Does that look okay? I did it kind of quick. I don't trust myself. Let's see. Yeah, it looks good. Yeah, it looks good. Looks good. Looks good. Okay. I think that's right. All right. This time I left a little room, right? Just in case we need more resolution, right? So let's see. So now again, I can kind of tell myself, there's the points, Jeff. So -4, -5, 0, -3. So far it looks like it's okay. The thing is, the one thing I might want resolution for is I don't know if it bends this way or if it bends that way, right? I don't know if you guys are with me. I don't know which way it necessarily bends, but I'm just going to assume it's bending that way, just because. What's this one say? -2, -1. Kind of makes sense because now it's got to make this turn. You see what I'm saying? -2, -1. -4, 1, and then 0, 3. No, Jeff, so. Look at that. It's the letter S. It's like a graffiti S. All right, cool. Also known as urban artwork. All right, is everybody cool with that part? Not bad, right? Again, I left some room. I ended up not needing it for resolution and so forth. Okay. What the shit does that mean? Who remember, what's the parameter? T. T is the parameter, right? X and Y are variables. T is a weird other level variable. We call it a parameter because it's controlling both of my true variables. So we just call that kind of behind the scenes dude a parameter. I want to eliminate the parameter, right? So I want to stake him out, see what his actions are, and try to get him, kill him. Which one of these can I solve for T more easily? The Y for damn sure, right? This is what I get when I solve that for T.
-3 over 2.
No.
Y plus 3 divided by
Add 3. Divide by 2. Is that cool?
Yeah.
I think you were trying to set equal to 0 or something. I don't know. So you got to add 3, right? And then divide by 2. Is that cool? To get T by itself? So now I know what T is, right? So in the X equation, I can replace T with what it is. And I wouldn't make you simplify that. That's a little gross. Yeah,
Oh, you forgot the squared on the second one.
I did. Thank you. Shaboo. Now, just to show you, if you stop there, I'm cool with it. But just to show you, don't worry about this. Do you guys see how there's 3y plus 3 over 2's? And 2y plus 3 over 2's? So I could factor out a y plus 3 over 2. I could factor 2 of them out. So then I have 1 left here. Like that. I mean, that's a little better. But again, it's fine if you stop here. Do you see how this is x as a function of y? Do you guys see that? So let me ask you this. Is this a function? Is this a function? What does it not pass? It doesn't pass for a line test. So when I say is it a function, I inherently mean is it y as a function of x? If I do this, is that a function now? Shit, yeah, because it's x as a function of y. Do you guys see that? Doesn't work this way. It's not y as a function of x. It's not y equals f of x. It's x equals f of y. So this way it's perfectly fine, yes? In fact, it looks kind of cubish. Why does it look cubish? Because the dominant thing that goes into building it is freaking cubish, right? Do you guys see that? Sort of? Maybe? No? Screw you, Jeff? Okay. That was all a little extra, what I just said. This is one of my favorite ones. You ready? Oh, did I bring them? Shit, I'll just show you. Damn it. I didn't bring my calculators. I didn't even bring my own damn calculator. You're awesome, Jeff. Okay. So I'll pull up Desmos just to cheat a little bit here. If you have a calculator, go ahead and try to put that last function in there. Do you guys remember how to do it? You got to hit mode. I think it's the third or fourth option. You got to go from function, change it to parametric, right? You guys see that? I think I showed you that before. So I'm going to put in here, oh shit, I got to remember how to do this. Oh, fudge. I don't use this as much for parametric. I'm going to cheat a lot. Oh, okay. So this would be t cubed minus 3t squared, comma, get out of there, comma. Let's see if I read this correctly. Oh yeah, and it goes from, what was it? -1 to 3. Why am I doing that, Jeff? Okay, I just got our S. All right, Jeff. That was a good little practice, Jeff. You actually don't want that. How's your math teacher? Oh, he talks to himself all the damn time. All right. 2 sine 2t. So if you want to use Desmos for this, do you see how it works? It's kind of nifty. You write them as if they're points, so the x piece, comma, y piece. Ooh! I had forgotten what this was supposed to be. And I didn't say, it's funny, no matter what I do here, if I go from -4 pi to pi, it's still, so it just kind of retraces itself. What shape is that? I like it. Oval, ellipse. And it's really neat because it's been turned, right? So, I mean, this is where, if you wanted to, this is where young Jeff would have played with this all day and said, well, what if I make one of the angles 3? Oh, look at that shit. What if I leave that alone and I change the coefficient? What if I change this one to be 4? What if I change this one to be 7? I mean, come on. Come on. No? Is anyone like, okay, that's nifty, that you can actually get an equation that gives me something that looks like something you would trace on the floor to do some kind of alchemical ritual thing. Don't try it at home, kids. Yes?
When it says eliminate the parameter is the t.
Yes, good. Exactly. X and Y are variables. T controls them. So one way we use the word parameter, because it's different in like statistics, but math uses the word parameter to mean something that controls the true variables. T controls X and Y. So it's like a level up from a normal variable, right?
Mine just looks like a line.
Oh, sorry. If you do it on your calculator, you have to go to Window, and do you see where it says T min, T max?
Mm-hmm.
Change it to make it -10 to 10, just to be, because this didn't really have a. Now, if you graph, what do you get?
Oh, now it's. I don't know what was going on. Okay.
Is that cool?
Yeah.
By the way, remember, real quick, can you do it real quick, Jeff, maybe? This one we just did.
2t minus 1.
Now look, we got this piece of it, right?
Mm-hmm.
If I let the range go further, I get more of it. And sure enough, if you turn your head, isn't that a cubic? How far will it go? I don't know. It depends on. So if I change the value of t, I cut off part of it because now it starts at 0 for t, and that doesn't pick up all the points, does it? Okay. In fact, that first one we did, shit, Jeff. I got to do it now. Crap and a half. What was it?
1/2
1/2
t squared
t squared
minus
minus 4.
4.
Okay. So if I go, no, Jeff, no.
And is it -4?
So we got this piece of it, right?
Yeah.
All right. So, but if I let it go further, is it doing what I said it would do? The x parts are between -4 and 4. Of course they are. But the y parts, isn't the y part parabolic? Shouldn't it go like that? So the y parts just go crazy. But the x parts have to live within -4 to 4. So if I made this 6, now it makes it wider, right? You guys sort of with me? I don't know, there's not much else I could do that would be interesting here. What would happen if I did
It looks like
that?
this-
Not very
this
interesting.
Interesting.
What if I did,
Lampstands.
what if I did, ooh, look at that.
Oh,
This. Whoa! Sorry. All right. Okay. So, again, as you do your homework, I need to see the work, but you sure as all hell can use your graphing calculator or Desmos. Desmos is stupid powerful. If we had more computer labs, we would teach pre-calc on Desmos. I mean, but we don't, because we don't have much money. So, yes.
Do you go to the y equals in order to see the extra of the graph when you're doing homework?
I'm sorry, on your graphing calculator?
Yeah, but where would we go to put that equation in?
Oh, let me see. I'm gonna take this off. It's fine. No, I'm joking. So if you hit y equals, no, Jeff. If you have like, oh shit. So right now this is set to polar, right? That's why I see R's. If you go to mode, parametric. And then when you hit y equals, you're gonna have bam, bam. Yeah. Sure. Okay. So if I ask you, or if the book asks you, eliminate the parameter, pick one of the equations that's easiest to solve for t, solve it for t, and then plug that shit into the other one. If you do that, t is gone. Can you always do that? No. There will be, can you imagine, for example, I could very easily do this and it would become basically impossible. You could do it, Jeff. There, no, that's the wrong thing.
So on the homework, if there is something like that where it's impossible to eliminate.
They won't ask you then. So if I would have changed y, if I would have made y this, y equals t to the fourth plus 2t to the fifth minus 7 divided by t. Can you solve either one of these? Do you guys see how you cannot solve either one of these for t? To be really, really honest, yes, you could. It would be unbelievably gross. Now, there are situations where I just couldn't do it. What if I had x equals t e to the t squared minus 1 over t, and y was sine of t squared plus 4 pi t? Impossible. You'll still get a picture, of course. You just cannot kill t. All right, that's more. Okay. So let these sections be not that evil. Let them be what they are, which is relatively nice. All right. So, what are we talking about today? I don't know. I'm going to talk about vectors, and then I'm going to tell you something. But let's talk about vectors. Has anybody ever heard of vectors? Yeah. What have you heard about them? You're like, dude, I just heard of them.
I remember a ton. I had a physics class and we just talked
Oh,
about
dude.
vectors.
All right. If you've ever taken any amount of physics, your physics teacher will talk about vectors all the damn time. So, I don't know if you guys know, but I'm also a physics guy. I have 2 masters. They don't add up to be a PhD, unfortunately. So, make sure you go for that full PhD. Oh, man. So, vectors are near and dear to my heart. Anybody else ever heard vector and kind of remember what context it was in? So you use vectors for every damn thing, right? Heard of the name.
No idea.
So watch, let me show you this. This is kind of cool. I don't know if you guys ever, get out of here, ad. Okay. This is a wind map that is currently not moving. There we go. What happened to you when that? Oh, it is moving. I just got to zoom in. Any of you ever seen this before? It's not doing what I want it to. Damn it. Is it because I zoomed in? All right, wait a minute. Let me refresh the page. Refresh the page. Here we go. That's better. Let me just leave it there. Can you guys all see that? Oh, shit. Can you guys see that? If I zoom in, apparently it doesn't do what I want it to. Can you guys all see that? All right. Where's the wind stronger? You don't know shit about this map, but where's the wind
Near
stronger?
ocean,
Over the ocean. How do you know?
because
There's more.
one, it's going faster, and
There's
two,
more
the
movement.
lines are longer.
Lines are longer. I like it. Now they added the fact that it's going faster too. That makes it really obvious. But a longer, by the way, these are functionally vectors. So a vector, the direction it's pointing has meaning. And if it's a vector showing wind, the direction of pointing obviously is the direction the wind's blowing. The longer the vector is, the stronger the thing is. So I could be measuring weight. So if I had a very light thing, it would have a vector pointing, a small little vector pointing down, right? If I had a really heavy thing, its weight would be a big vector pointing down, because that's the direction that its weight is acting. You guys all, that's why we don't float, because weight's acting down. Okay, I like it. So is that, you guys, it's kind of cool. I like that because it's a nice visualization, and you immediately, now I don't like, there is another one, I couldn't find it, that doesn't make it faster and slower. It's purely length, because all you need to know is the length means whatever that's representing is more, right? So let's come make this a little more mathematical. So here is a vector. Look at that. So let me tell you a little bit more about it, right? The terminal point of this vector is, let's say, 3, 4. You guys with me? What's the initial point of this vector? You can see it. What's the initial point? 0, 0, right? So here's a nice thing. We would actually call this vector, we would call it, I could call it something like V, and I normally put a little vector symbol above the V. So that's vector V. So you can call, normally for vectors we use U and V. It's kind of like X and Y for points and numbers. For vectors we use U and V. This specific vector's name, its specific name is this. Do you see how we use different symbols? Are you guys semi with me? Is there, again, this is just some notation. You can see where the notation comes from, right?
So the little symbol on top of the V stands for vector?
Exactly. Sometimes you'll see like this symbol, and that might make more sense, but I'm not going to remember to do that because I've always done vectors that look like, so here's a vector, here's a vector. In textbooks, they sometimes have vectors as a bold. They don't put a little thing over it, they just have it in bold. I can't do bold easy on here, so you also see with the little symbol.
So if you have that symbol above the letters, why would you even need to use the letters if the symbol means
So it's
vector?
the name of the.
Because I could have, what about this vector? Let's call this W. And let's say it's -2, 1. So now vector W is -2, 1. Do you see what I mean?
Okay.
It's sort of like angle A, angle B. So we didn't really use this symbol much, but isn't that the symbol for angle?
Yeah.
So what you just said is basically, why would I need the letter A? Well, because to distinguish it from other angles.
Okay.
Yeah, I like it. Yeah. Can anyone figure out how long vector V is? Yes, you can. It's easy shit. Come on. You can figure out how long vector V is. You totally can. Of course you can. No. I want to know, how long is this? Is it more than 3? Yeah, how do you know it's 5?
Triangle.
There's a triangle right there. There's a triangle. Do you guys see it? So isn't this 3? Isn't this 4? So doesn't this have to be 5?
Yeah.
Okay.
So in general, how would you figure out how long a vector is? X squared plus y squared square root, right?
Mhm.
Oh, so you can use the five here.
Totally, because all vectors really are this. This is what a vector is. The minute I draw it, it's made a right triangle. So this is why we teach vectors immediately after trig. Because you can attest this. Vectors are all about the trig. All about the trig. No, Jeff, don't. Okay. So the length of V, and does this symbol look familiar? We use this symbol to indicate length. It's absolute value. So, real quick. Back in the day, when I said, what is the, Jeff, you could do it, buddy. There it is. That's not negative over there. And when I said, what's the absolute value of -4, what I was really asking you is, what's the length of this vector? We didn't say it like that because we didn't know what the flip vectors were, right? But you guys, now that symbol really means the length of the vector, which is another reason why it's always positive, because you can't have something have a negative length. We can, but let's not go there. So this would be 5. Take a second and figure out what this is. Don't say it. Figure out what that is.
Wait, what was
Figure out what that is. There's W. So what work are you guys doing? Good.
negative
Square root of?
-2 squared plus 1 squared?
Mm-hmm. Square root of?
5.
There, done. Yay. Which makes sense. It's smaller. Poor little dude. Smaller than this guy. How are we doing? Reasonably well? Okay. Yes.
I don't get how we got root 5 in the middle.
Oh, so look at this triangle. Right? This is 1 and this is 2 here, -2, right? So how would you figure out how long this side is? Wouldn't you just do Pythagorean theorem? And then it would be equal to this squared, so we just square root. So in general, if I'm given a vector, let me call it u. So everybody cool with that? That's a vector. A could be whatever, B could be whatever. How do I figure out how long it is? Square root of?
A squared, square root of A squared plus B squared.
Kick ass, right? And again, different symbols, correct? Different notation, old ass math, correct? The math involved, we've known it forever. The symbols and kind of the meaning, a little bit different. Okay, I like it. Now, coming back to, let me redraw this. Coming back to, what was it, vector V? So one thing that vectors have going for them is magnitude. Let me bring that word in. The magnitude is just the official name for length, how long the sucker is. So depending on what the vector represents, magnitude could be the strength of it, it could be the weight of it, it could be whatever. The force, newtons. Okay. Can somebody tell me what the angle that it's pointing in with respect to? Nope. 45 would mean these were the same length.
Do we go back to
Don't guess. Don't
the-
guess.
We go back to that, to the yeah.
What's tangent theta?
Y over X,
Yes, so it's,
so it would be 4 over
So what's
3.
theta?
Inverse tangent 4 over 3.
so have you ever heard somebody talking about the wind being very specific? They could say it's 11 mile an hour coming north of east, or you could even hear, if it really is important, you'd hear somebody say 11 degrees north of east. So we're calculating that angle that represents the direction this is going in, which is very important, right? If I'm in a sailboat I want to know that shit. I don't know. So what's that? Is that what is it?
53.13.
4? 13?
Yeah.
Okay, sounds good. Okay. All right. Let me see. What was the other thing I want to talk about? Yeah, there's. All right. Let me introduce a couple more things. These vectors are very special. Aw. Can somebody tell me what the name of that vector is? Not the letter, but just tell me what the name, like this.
Oh, 0, 1.
This one, this one, this one, 1, 0, correct?
Oh, yeah.
I'm going to call him I hat because I'm weird as shit. What about this guy?
0, 1.
That one's 0, 1. I'm going to call that J hat.
So what for the other ones that we only have one?
Say again, sorry?
For the other examples that we were given, we only had one, like we had 4, 3.
Yeah, totally. We had 4, 3 because that's the point that it's pointing to, right? What's the terminal point of this vector? 1, 0. So that's its name.
Oh,
Okay. These are just the basic building blocks of stuff. Let me see. Can somebody tell me what I hat plus J hat would be? What would your gut tell you? I hat plus J hat.
1, 1.
1, 1, exactly. What does that mean? If I walk 1 block over, that's this. Plus, I walk 1 block up. Where am I at now?
1, 1.
And that's exactly the answer. Yes.
So I'm guessing the new symbol you used is just another symbol.
Oh, this will do. Yeah.
Yeah.
It's because these are how long is this? You don't have any work to do.
1,
1. How long is this?
1.
These are unit vectors. Specifically, they're unit vectors that lay in the direction of our axes.
Okay.
Those are really important vectors.
So the little hat symbol is when the
It's a
vector is
unit.
laying
It's a yeah.
on
Yeah.
the axis, and then the other symbol is when it's in a diagonal.
Just a general vector. Yeah.
so since there's two, like two vectors, is that what it is?
Yeah.
On the one and the other one, that means you have to have two separate, terminal points?
Oh, here. This one. Yeah. This was a vector, and that was a vector.
Yeah.
So I had this was the name of that vector, and this is the name of that vector.
by unit vector, are those just the ones that are given?
What did unit circle mean? The radius was 1. Unit vector just means it's got a length of 1.
No, okay.
Yeah. So you can have a unit vector that's not on the axis. If it's on the axes and it's a unit vector, it's I and J.
So then all unit vectors have.
All unit vectors have a length of 1. Yes. So coming back real quick, watch this. This is kind of neat. See how this is 3, 4? All right, let me blow your mind a little bit. This is 3I plus 4J. You agree with me? What was I?
Yeah.
I is 1, 0. So if I put 3 of them, wouldn't that get me out to 3?
Mm-hmm.
And if I put 4 J's, that would get me out to 4. And if I add them together, that would get me there.
Okay.
So these are 2 different ways to express any vector, either in what's called component form, and I actually forget what the hell that's called. I don't think maybe it doesn't have a name, I can't remember. Oh well. So you can see the little building blocks that vectors are built from, right? One last thing I want to talk about vectors. What if I had this vector? Sure. Okay. Jeff, what is that? Pretend like that's straight. It's not supposed to be curved, damn it. That's a vector. What is its terminal point?
Uh, 4.
Well, I've got it kind of like pointed this way, right? So it'd be 4, 1. Okay. Why is that not its name? Its name is not 4, 1. That is not its name. This vector would be 4, 1. So what's important is it's got to start here at the origin. So if I have a vector, do you agree that wind could be just every damn where?
Mhm.
But this is just a vector that's been moved.
Yeah.
Now watch this, kind of cool. To get to 0, how much do I have to move each point? How much do I have to move this point? I have to move it back 2,
2.
down 3.
Or 3.
Right? So if I take 4, 1, and I move it back 2, down 3, where do I end up? 4 minus 2.
2 negative
2, negative 2. Jeff, you can do it, buddy. There it is. So the shortcut to this is the point 2, 3. This is the point 4, 1. So to get the actual name of this vector, it would be, you could do it, Jeff, 4 minus 2, comma, 1 minus 3. That's just translating it back so that it starts at 0. Okay, maybe.
So does it always have to start at 0, or does it?
In order to name it using this notation, the initial point has to be 0, 0.
Okay, so it can't be like on the y-axis. It has to be like, say it was like at 3. It started at 3. We would have to.
We'd have to move it down. Yeah. So real quick, isn't this vector? That's vector 4, 1. Yes. Is it going the same direction as our vector? Is it the same length as our vector?
No.
Totally different vector. So I cannot call this vector 4, 1 because this is vector 4, 1. And it's totally different, right?
And then you would just use your new point that you have.
That's the name of our vector.
To make the.
So then I know, and so my picture sucks a lot. So it should be 2, negative 2. So it should be here, but oh well, too bad. My scale sucks bad on
But
this.
then you could use that new point to find its length.
Yes, totally. Yeah. I like it. Okay. And so like I could pick this vector up and move it over here. It still has the same name. It's just been moved. That's all. Still has this name. It's just been moved.
Because it's pointing in the same direction.
Because if I put it back, it would terminate at 3, 4. That's what their names are based on. Where would it terminate if I put it back up from the origin? Okay. Now that I've said all that, I'm going to make section 10.8 extra credit also. Why not? Let's make a bunch of freaking extra credit. Why not? So 10.8 extra credit. Because there's more to the story than what we've done, obviously. And we just don't have the time, unfortunately. So if you're, I will say this, if you are going to go into physics or, well, physics really, you probably want to try this extra credit, right? If you're going to take physics sometime in the future. If you're not, then it's really up to you if you want to try it or not. You can see how it's just trig with, Pythagorean theorem and stuff. So it's stuff we've already done. It's not that evil. But we just don't have time to really dig all the way into what we have to. So what we're going to do is this. Everybody's got this, of course. Yep, sorry.
Sorry. How did you get the new point again?
Oh, this guy?
Yeah.
So you take, see how it ends here? So take the end x minus the initial x, end y minus the initial y. Bam.
Oh, okay.
What is the line that you drew?
This?
Yeah.
That was me trying to move that back. If I pick this up and I put it down here,
Oh.
yeah. Now, of course, my scale sucks a lot.
Okay.
And this was longer than it should have been, but it should have ended at this point. Okay. So, come back to this. Everybody's got this, right? Everybody, okay. Leave that. We're going to need that in a minute. Do you guys remember, we've done this before. Believe me, we've done worse problems than what I'm about to write down. Do you guys know how to solve, actually, let me real quick do a little more to this. How many answers are there to this, what I just wrote down? What are they? Huh?
Well, if you're solving for y.
Nope, nope. How many answers does this have?
One.
Let me ask you this way. What is this actually saying? What are x and y? What are they? Two numbers. So what is this asking? What two numbers add to 6? Are there only two numbers that add to 6?
No.
So can somebody give me one answer?
3 and 3.
Give me another answer.
1, 2. 5 and 1.
Holy shit. What about 10 and -4?
Yeah.
Dudular. Right? And so how many answers are there? Infinite number. Holy shit. Which is why we graph it. That's the quickest way to answer what are all the answers. I don't want to do it this way. I'm just going to graph it. If you don't see the answer you want, follow the damn arrow. Leave me alone, right? So if I ask you to solve this, an appropriate response would be no. But what if I also tell you that the same two numbers, when I subtract them, what do you get, Jeff? I get 2. Is there a single answer now? In fact, we've already written the answer down, haven't we? Does anyone see what the answer is?
4 and 2.
Yeah, 4 and 2. If I graph both of these, let's take a minute. Here, you guys. Here, I'll do this. Solve for y, I get -x plus 6. Solve for y, I get x minus 2. Can you graph those for me on the same? Try to be a little better than me at scales. Jeff, you're going to have to go further up, buddy. There it is, my friend. Shite. Down 1 over 1, down 1 over 1, down 1 over 1. Okay. Up 1 over 1, up 1 over 1, up 1 over 1. Make these big. Whee! Where do those lines meet? And what was the answer? So when I plot, when I plot a line, I'm plotting all the answers to that equation. So the question here really is, when are these both true at the same time? There should be like an intuitive sense, well, visually it's where they frickin' meet. If these are all the answers to that equation, and these are all the answers to that equation, where's the answer that works in both? Well, they meet, right? Okay, you guys with me? So anytime we solve a system of equations, not system of a down, system, it's just one system, system of equations, I can interpret the answer as the point where the lines would meet. Does every set of two lines meet?
No.
No.
So if I have two parallel lines, what do you think the answer is going to be? No solution. If the answer is where they meet and they never meet, there's no solution. Okay. Does this sound familiar to anybody? Have you guys ever worked with this stuff before? If not, does it make sense so far? He says. So, if the answer graphically to a system of equations with two variables in it is where two lines meet, what if I have something like this? Let me ask you this. So let's talk a little bit about this. Can somebody give me one answer to this? Sure you can. You can do it. 1, 2, 3. 1 plus 2 plus 3. How many dimensions are we in now? Finally. We're not all in flat world. Like, we're finally going out, but now we're in 3 dimensions. X plus y equals 6. Graphically, that's a line, correct? X plus y plus z equals 5 is the next step up from a line. X plus y plus z equals 5 is a plane. So how many unknowns were there in the first problem we did? And how many equations did I need to be able to solve it? 2. Makes sense. In real life, if I'm trying to solve a murder and there's 5 things I don't know, I'm going to need at least 5 pieces of information to kind of like tie them all together. So I always think of this as like trying to solve some mystery, murder mystery or something. If I have a bunch of unknowns, I need to gather a bunch of information to fill in those unknowns. Okay. In mathematics, it's a perfect match. If I have 3 things I don't know, I need to have 3 pieces of information. So let me do this. Let's do this. Let's say the answer is supposed to be 1, 2, 3. I'm going to make another equation. Now watch this. So if I put 2x minus y plus 3z, if the answer is supposed to be 1, 2, 3, can anyone tell me what number I should put there? And of course, this is not what you're going to do. You're going to answer questions that have already been created. But right now, I'm letting you help me make a problem. Can anyone see what number has to go there so that 1, 2, 3 is the answer? If 1, 2, 3 is the answer, what's x?
9. Or, sorry, the
Oh,
answer is 9.
All right. If 1, 2, 3 is the answer, the x is 1, correct?
Yeah.
So this is 2 minus 2 plus 9. 2 minus 2 is 0, plus 9 is 9. That's crazy. So somebody help me out. Make a third one for me. Start me off.
3x
3x, no way.
minus y.
Sure. Let's do minus.
20z.
Get out of here with that shit. No, it could be 20, who knows. So what number needs to go here?
1.
So 3
3 times
minus 2 is 1. Minus 12, negative 11. Now let me make sure. Does everybody understand what the hell I just came up with 12 and all that shit? If x is 1, that's 3, yes? Y is 2, so that's 3 minus 2, that's 1 so far, yes?
Yeah.
Z is 3, that's minus 12 then, right? 1 minus 12, negative 11. So this system of equations must have this as a solution. So how the shit? First off, can we graph this? Not easily. We're not going to suddenly start graphing 3D. Don't freak out. But real quick, x plus y plus z equals 5. Does that make some sense that that would be a plane? It's like the next step up from a line. So if I have one line, but then I give it one more dimension, does that make it a plane now? It's just that line repeated forever? So let's say that first equation, does everybody agree with me? This is a plane, basically?
Yeah.
This plane. So that first equation is this plane.
Mm-hmm.
The second equation is the ceiling.
Okay.
And the third equation is this plane, this wall. Where's the solution? Shit, I should have picked 3 different ones.
In that corner?
In the corner back there, yeah. I should have picked the one over here. So if it was this plane, the ceiling, and the back wall, the solution would be the point in the corner, because that's where they all meet. It's exactly the same idea as 2 dimensions, just now it's in 3 dimensions. It's crazy. So we're not going to graph these. Don't get all freaked out. We're not going to graph planes, because that's not easy to do. 3D graphing. I want to, before we try to, then how the hell are we going to solve this then?
Well, wouldn't we have to solve it for each?
So, going back,
For each letter?
let's talk about the algebra behind this, because now we're getting to a point where I can't graph it, and I don't necessarily, do you want to try to make a list of all the, we're pretending like we don't know the answer, right? We don't know the answer. We know the answer, but we're pretending like we don't know. We got to figure out how to solve this. So let me come back to this. Does anyone know a different way to solve this than graphically or guess? Sort of, yes. I think I see what you mean. So let me write it again over here. Well, let me do this first, and then I'll come back. I know what you mean. Let me do one thing first. We've already done something before. Isn't there too many damn variables? Can't I just solve?
Get 'em on.
Can't I solve for one
Yeah.
and then plug it in?
Yes.
Right? We've done that before. We just did that earlier today with the T shit. Right? So this is what's called substitution. Solve one equation for a letter and then plug it into the other one. What does that do for me? How many variables do I have in this equation now? One. So I can solve for it now. I've decreased the number of variables in my problem. Always better. 6 minus 2y equals 2, right? Subtract 6, negative 2y equals negative 4, y equals 2. The great thing is, once I know one of these, it's like dominoes. Not the pizza, sorry. It falls back. Now I know y, which means I must know x. And isn't this the answer we got before? Become an x. Damn it. Okay. So the point we got before was 4, 2. Same answer, right? Does someone know another method? Because the substitution method quickly becomes not the preferred way to do things, trust me. Especially when we get 3 variables. Say again? Elimination. Now, real quick. If I add something to one side of an equation, don't I have to add the same thing to the other side, right?
Yeah.
That's the math 001 shit. All right. So if I add 2 to this side, I get 8. That's amazing. Don't I have to add 2 to the other side?
Yeah.
Isn't 2 equal to this? So if I add 2 to this side, I can just add this to this side because this is 2. Don't you agree? This is 2. So on one level, you should balk at the idea that you're able to just add 2 equations together. You should go, what? But it's because of what I just said. I am adding 2 to both sides because x minus y is 2. So if I add 2 to this side, I'm going to add 2 to this side. So what do I get? X plus x, 2x, careful, I'm adding. Y minus y,
0.
dead.
Yeah.
So then if I divide by 2, look, I get 4 again. Of course I do, because that's the answer. And then if I plug a 4 back in, 4 plus 2, so I still get 4, 2. You guys semi with me? How much time do I have? Not much. Great. So coming back, where did I put him? This guy. This guy. This guy. Why does he suck so much more?
Because he has 3
God
variables.
damn it.
instead of 2.
So if we had, if only it was this, we could do that shit, right? Yes?
Yeah.
So how do we get there then? I pick a variable and I kill it twice.
What do you do?
If
Snap
I,
that?
for example, if I look at the Y's, do you see how they want to die easy?
Yeah.
And again, excuse my language here. It's a lot of blood and death and such when I do this. Do you see what I mean by that? If I add the first 2 equations together, doesn't the Y just die?
Yeah.
All right, it wants to die. We're compassionate. Right to die. Okay. So 1, 2, 3. Always number the stuff you're working with, right? So if I do 1 plus 2, what do I get? 3x. No y's. 4z, right? Now, real quick, does everybody see where all that came from? Yes? Okay. Yes? It's almost too nice to believe that we're allowed to do that. But again, we are adding the same thing to both sides.
And then now you can solve.
Now, real quick, I've got one equation with only x and z in it. If I had another equation with only x and z in it, we could do it the way we just did earlier.
Yeah.
How do I kill y in a different way? I can't use 1 and 2 again.
You can take 1 and 3.
1 and 3. So what's 1 plus 3? Yeah, 4x. Y's die. Z minus 4z is 5 minus 11. Cool. Now here's our first little challenge. Does any variable cancel directly? Don't you? We wish that the coefficients, bless you, were the same. Specifically on which variable? Which variable already are opposite signs? The z. What's up, Ellie?
I was just gonna ask what this method is called.
Oh, this is the elimination method.
Oh.
Yeah. So we have substitution method. Substitution method would suck here. Elimination is just much more straightforward. I really want you guys to be with me on this. This is the first time we've seen this, but now I kind of want us to get here naturally. Yeah.
Doesn't 1, 2, 3 not work?
What do you mean? Sorry.
1 plus 2 plus 3 is 6.
1 plus 2 plus 3 is 6. Yeah? Why? What do you mean?
X plus
Put
y plus
five.
z is 5.
What did I put where? Sorry.
1
You
plus
s-
2 plus 3 is 6. X plus y plus z is 5.
Damn it!
Yeah.
All right. I wasn't thinking when I was talking about that. All right. Let's do this. Let's salvage this. Thank you, Paul. Feel free to add, I'm human. Sometimes I say 1 plus 2 is 7. It's neat. All right. So that is 6. Thank you. You saved this, by the
So
way.
then,
Please, dear God,
One.
speak up. It's fine. So real quick, what's that change? When we did 1 plus 2, this should be 6 plus 9. That should be 15, right? And when we did 1 plus 3, 6 minus 11, that should be -5. Is that cool? Okay. Okay, thank you. Yeah, thank God I am not a teacher that's like, oh, I'm always right. No, screw it. Screw it. Now, real quick. Does everybody agree that the z's, they already have this different signs? Which is good. I want that. What number can I make them both multiply up to be? It's like an LCD. I can make them both multiply up to be 12. What would I multiply? So watch this. You guys are ready for this? This is my fourth equation. This is my fifth equation. Is everybody with me? So what do I do to the fourth equation? I want to make this 12. And then I want to make this 12. And you guys see that I could then make the z's cancel, right?
Yeah.
All right, so what do I multiply 4 by? 3. So I get
Uh,
9x plus 12z equals 45. What do I multiply the fifth equation by? 4. So now I get 16x, which is what we wanted here, right? -20. So if I add these together, let's see what we get. 25x equals 25. Is that cool? Z's cancel.
Yeah, and then x is the equal.
X is 1. Which is, thankfully, what it's supposed to be now. Okay. Now listen. I know what x is now, right? We all know what x is. What's the letter I can immediately get now? What has a direct relationship with x?
Y.
Z.
Oh.
Y has a relationship with both. In order to figure out y is, don't I have to know what x and z are? So this is like, again, dominoes. I know what x is. Let me fall back one level. Now I can figure out what z is. I can pick either one of these damn things. If I put a 1 in for x, I get 3 plus 4z equals 15. Minus 3, 4z equals 12. What's z? Holy shit. And now that I have x and z, I could fall all the way back. X is 1. Z is 3. So that means y is 2. Kick ass. 1, 2, 3, like it's supposed to be. With the assist. All right. Now listen. Does that sound familiar to anybody? Anybody ever did this kind of thing? Some of you guys haven't. Even if you haven't, can you see how it's very recipe-ish? So I didn't get to this, but Where'd it go? Scheisse. Too much paper. On the back of this, yeah, here we go. This one, I have a whole worked out example, right? You with me? And this time I got 3, 2, 1. I'm very creative with my numbers. So you have this as an example to help you. This is, by the way, this is section 11.2, I think. I think it's 11.2. That's plenty. All right, you guys get out of here. Let me know if you have any questions. Have a good weekend.